Here are a couple of examples of using autograph in the context of teaching physics or applied mathematics. We have best fit to data, where we've got some tied data and fitting a trig function to it. And over here we have a distance time situation. So I'll just minimize that, open up a new page, and window, tile, vertically. So I've got the two next to each other. So I'll just get this situation over here, and then you can see how it's all put together. First of all, we need to change the variables from x, y to t and s. So we double click on the axes, or you can do edit axes up here and have a look at the labels. This is where it's done. So we want to change x to be t, and then the label wants to be t : time in seconds, and then this one wants to be s, and then s : distance in meters. Now that means that any equation you put in is going to allow variables s and t. So we could right click, enter an equation. Let's do s equals ut plus a half, which is there, half a t squared. Now we want the initial acceleration to be negative 9.81, so it's gravity, and the initial velocity, say, 10 meters per second. So that should draw a parabola, and it's going to be an upside down parabola because the t squared term is negative, so it's going to be like this, and it's t is a factor, so it goes to the origin, and off we go. Now I've got the slow plot on, which means it's plotting slowly and will therefore appear from down here, come through here, and then back down here. Now we need to get the scales right, so again double click, and I'm going to go from x to be -1 to 5, and y to be -5 to 15. And we'll give that some thought. We'll look at these in a second. And now I think these horizontal grid lines are too frequent, so I'm going to double click again and change that not from the default of 1 but of 5. That's better. And then to get the graphing appearance, again it's double click on here, appearance, and use one of the preset themes. And the one I'm going to use is graph paper. And still one or two changes to make. I like these to be a bit bigger. This theme does actually change lots of things. So I'm going to again go back to edit axes and look at the options. You can see that subdivision is 5, that's how it's getting this effect. I just need 2 entries down here. And in the appearance, I think the axes numbers are okay, but the axes labels I'd like a little bigger. So I'll put those to 14. And I want the key font that's down here also to be 14. Okay, we're all set. Let's fast forward that. Looks like I've made this a bit thicker as well. Select that and thickness here at 4.5 point. Right, this is distance time, and I think what I'm going to do is put a point at the origin. So I'm going to select that and right click, enter point on curve at 0, which is correct. Select that point and right click, draw a tangent. Now the initial velocity was 10, so we expect the gradient of the tangent at the origin also to be 10. Is it 1 along, 10 up? Yes, perfect. We could display the equation of the tangent by selecting it and going to the text box, and you can see that it says tangent. Anything in black you can edit, so I'm going to do tangent at t equals 0, and let's put an enter in there, and move that up to here, and swing that round to there. I'm also going to find the maximum point here. I'd be interested to know. Now, because it's 9.81 and not 10, the maximum is not at 1, it's a little bit beyond. So I'm going to select that and do a right click and solve for f dash equals 0. Now that could be many different results. So in fact, this object isn't necessarily a point, it's a collection of points, although there's only one on this occasion. So we need to put a point on it if we want to do anything else, for example, like right click, draw a vertical line, which I thought was quite nice to do. And then we click that and right click, edit, draw options, we can make it dotted. If we want to show the coordinates of this point, select it and text box and there it goes. And we might just replace point with max, something like that. Now to have a look at the gradient, I think it's a good idea to get the scribble tool out. Now at the moment the gradient is 10, as we know. But if I select this and drag this around, clearly the gradient is 0 at the top here, so it's definitely going to go through here. So if there is a gradient function, and if it's linear, which it would be because this is a parabolic expression, so the first derivative of that will be a first order straight line, and it's going to come down like that. This is the autograph way. Always try and think of things in advance using the scribble tool to try and predict what the computer's about to do. There's a lovely feature here that if we're on slow plot, you can click on this one to get the first derivative. It will slowly do what I've just been doing, in other words, drawing the tangents around the parent graph and then working out the slope. So watch this. Okay, so it's going to come through there, and it confirms that the 2 points we discussed are indeed on this line, and it stops at all the key moments, and on it goes. So this is the first derivative. If you differentiate this, you get v equals u plus at. So that's what I've done on this one. So I've deselected everything and select that, and here I put, instead of all this information which I don't need, convert to static text, get rid of that, v equals u plus at. So there's that diagram, and that's pretty much what's